Have you ever stopped and wondered how an AI, like ChatGPT, goes from basically being a giant database of the internet to, well, a helpful partner you can actually chat with? It's this pretty amazing journey, really, from just raw, brute force knowledge to a refined assistant. So let's get into it.
So the real question we're asking is this: how do you teach an AI not just what to say, but how to say it? I mean, it's one thing to have all the facts in the world memorized, right? But it's a completely different challenge to be useful, to be polite, and to be, well, aligned with what we humans actually want from it.
And this right here, this is the perfect way to picture the problem. On the left, you've got what's called a base model. The best way to think about it is like a library with every book ever written, but with absolutely no librarian. All the information is in there somewhere, but its answers are dense, they're rambling, and honestly, they're not very helpful. But then on the right, you have the aligned model. That's the polished assistant we're all used to. And that transformation, that's the magic we're going to unpack.
Now, here's what's so wild. The biggest improvements don't actually come from that first giant training phase where it just ingests the internet. That's kind of like building the car's engine and chassis. The real performance, the stuff that wins races, comes from all the tuning and adjustments they do after the car is built. It's the same with AI. This post-training phase is where a massive amount of performance gets unlocked.
Okay, so let's start at the very beginning of this whole education process. How do we take that chaotic, librarianless library and start turning it into something that can actually work as an assistant?
Well, the very first step is a process called supervised fine-tuning, or SFT for short. You could think of this as the AI's basic training, its boot camp. We take that raw base model and we just show it thousands upon thousands of high-quality examples of prompts and the perfect answers, all written by humans. It's basically learning by imitation. Like, okay, when someone asks a question like this, I should respond in a helpful, conversational way that looks like that.
And you can see that first step laid out right here in this classic diagram. The raw base model gets fed all these human-written instructions, and it turns into an SFT model. So now it knows how to follow basic commands and how to structure a conversation. But that's just step one.
Okay, so that brings us to the next phase, and this part is absolutely crucial. To go from just being functional to being truly helpful, the AI needs to understand nuance. It needs to get what we humans actually prefer. And to do that, we need to train a very special kind of judge.
And this is where it gets tricky, right? Because things like tone or style or what makes an answer feel good, it's almost like good taste. You can't just write down a set of rules for that. You can't just program a model and say, hey, be more helpful. It has to learn by example, by seeing what we actually like better.
So how do you even get that data? Well, the process is pretty straightforward, but the scale is just massive. First, you give an AI a prompt and have it generate a bunch of different answers. Then a human labeler comes along and ranks them all, from the absolute best to the worst. Now imagine doing that hundreds of thousands of times. What you end up with is this incredibly rich and valuable thing called a human preference dataset.
Now, you take that entire dataset and you use it to train a completely separate AI. This one is called the reward model, and it's probably best to think of it as an AI judge. Its entire job, its only purpose, is to look at two different answers to the same question and predict which one a human would have liked more.
And if we go back to our main diagram, you can see exactly how this fits in. The SFT model we made earlier generates a bunch of responses. Humans rank them, and all that preference data is used to train our reward model. So now we have our judge, and it is ready for the most dynamic and important stage of training.
This next part is where it all comes together. It's this powerful feedback loop. You can think of it as the AI's finishing school. It's where it learns all the subtle social graces of being a great conversationalist.
This whole process has a name: reinforcement learning from human feedback, or RLHF. And this diagram, this is the engine room. The AI we've been training, it's called the agent in this loop, gets a prompt and tries to generate a good response. That response then goes to our AI judge, the reward model, which gives it a score, a reward. And then the agent uses that score to update its own internal strategy for next time.
So let's just break that down one more time. The AI tries to give a good answer, the AI judge scores it. That score is a reward signal, good or bad. And the AI's goal becomes incredibly simple. Just keep tweaking its own internal wiring to generate answers that will get a higher score from the judge next time. And this loop just runs over and over millions and millions of times. It's just constant practice and refinement.
And through this relentless cycle of trial and error and feedback, the model starts to actually internalize what we mean by a good answer. It learns helpfulness, it learns the right tone, it learns a conversational style, not because we wrote down a bunch of rules for it, but because it figured out how to get the highest reward from our human-trained judge.
Okay, so that three-step process, SFT, training the reward model, and then RLHF, that's the classic recipe. But this field moves so incredibly fast. Researchers have already figured out faster and, frankly, smarter ways to get to the same result. And one of the biggest innovations here is a method called direct preference optimization, or DPO. It's a really clever approach that gets you to that same beautifully aligned model, but it lets you skip that whole step of training a separate judge model. It makes the whole process way more direct and efficient.
So what's the big difference here? Well, classic RLHF is this multi-stage thing, right? First you train the judge, then you use the judge in this complex feedback loop. DPO is way more direct. It uses the exact same preference data, the rankings of which answer is better, but it uses that information to update the main AI in a single, much more stable step. It's like it bakes the reward signal directly into the training process. No separate judge necessary.
And this side-by-side view really brings home how much things have evolved. On the left, you see that simple, foundational three-stage process we first talked about. But look at the right. That's a modern training recipe. It's so much more complex, right? It mixes in different stages, it uses DPO, and it even has specialized steps to target specific skills like coding and reasoning.
And it gets even more specialized. There's another method for teaching specific skills called reinforcement learning with verifiable rewards, or RLVR. This is for things where there is a clear right or wrong answer, like a math problem or a piece of code. So you can forget the subjective judge. Here, the reward is dead simple. You get a 1 if your answer is provably correct, and it's 0 if it's not. That's it. And just look at how much this simplifies the feedback loop. That complex, nuanced reward model is totally gone. It's replaced by a simple verification function. Think of it like a unit test checking if code works, or a calculator checking a math problem. This makes it incredibly efficient for getting models to be super accurate in these high-precision tasks.
Of course, none of this is perfect. It's always a balancing act. Early on, a really common problem was something people called too much RLHF. The models were trying so hard to be safe and helpful that they would just overcorrect. You'd ask it a totally harmless question, like how to kill a computer process, and because it saw the word kill, it would just refuse to answer. A classic case of taking a good intention a little too far.
So really, the main thing to take away from all this is that turning a raw AI into a helpful partner isn't some single event. It's a really sophisticated educational journey. It involves basic instruction, learning from our preferences, getting feedback from an AI judge, and just constantly refining its own behavior through millions of rounds of practice.
And that leaves us with a pretty fascinating and honestly a really important final question. This technology for teaching an AI to align with human preferences is getting incredibly powerful. But that just moves the problem up a level, doesn't it? As we get better and better at this, we have to ask whose preferences and whose values should the AI ultimately be learning?